Where is planet Pluto? Pluto, the most famous of the dwarf planets, resides in a region of space known as the Kuiper Belt, a vast, disc-shaped zone of icy bodies and remnants from the solar system's formation. Located beyond the orbit of Neptune, the Kuiper Belt is home to many small celestial objects, but Pluto stands out as one of the largest and most intriguing. This remote and mysterious world orbits the Sun at an average distance of about 36 billion miles 59 billion kilometers, or 39 astronomical units L. 10 is the average distance between the Earth and the Sun. So Pluto is significantly farther away from our central star than any of the planets. The dwarf planet's orbit is highly elliptical and tilted compared to the more circular and planar orbits of the traditional planets. This means that at certain points in its 248-year-long orbit, Pluto comes closer to the Sun than Neptune, although the two bodies will never collide due to their resonant orbits. From 1979 to 1999, Pluto was actually closer to the Sun than Neptune, despite its great distance from the Sun. Light from the star still reaches Pluto, taking about 5 hours to travel the vast expanse of space. Pluto is a complex celestial body composed of a mixture of ices and rock. The dwarf planet likely has a differentiated internal structure, with a rocky core making up roughly 70% of its mass. Surrounding this core is a mantle of water ice, which is coated by a crust composed primarily of nitrogen ice, along with traces of methane and carbon monoxide ices. The New Horizons mission, which provided the first detailed images and measurements of Pluto, revealed fascinating details about its surface composition and geological activity. The surface of Pluto is dotted with large mountains, some of which rise as high as 11,000 feet 3,500 meters. These mountains are believed to be composed of water ice, as the nitrogen and methane ices that cover much of Pluto's surface are not strong enough to support such towering structures. The presence of these ice mountains suggests that the bedrock of Pluto is made of much more resilient materials. In addition to its mountains, Pluto's surface features vast plains, valleys, and craters. One of the most striking features observed by New Horizons is the heart-shaped region known as Tombaugh Regio. Within this area lies Sputnik Planitia, a smooth, craterless plain that appears to be composed of nitrogen ice. This region is relatively young, geologically speaking, with an estimated age of no more than 100 million years. The lack of impact craters suggests that geological processes are actively reshaping the surface, possibly through convection within the nitrogen ice. Another fascinating feature of Pluto's surface is the presence of ice-ridge terrain, which resembles a snakeskin pattern. These ridges are similar to penitents found on Earth, which are erosion-formed features on mountainous terrain. However, the ridges on Pluto are much larger, reaching heights of up to 650 feet 500 meters. Such features indicate that Pluto's surface is shaped by both external and internal forces, including solar radiation and geological activity. Pluto's thin atmosphere, composed mainly of nitrogen, methane, and carbon monoxide, is a dynamic and complex layer that undergoes significant changes depending on its distance from the Sun. When Pluto is closer to the Sun, its surface ices sublimate, transforming directly from solid to gas, which temporarily thickens the atmosphere. As Pluto moves farther from the Sun, the atmosphere collapses, with gases freezing back onto the surface. This cyclical process creates seasonal changes on Pluto, much like seasons on Earth, although they occur over much longer timescales due to Pluto's lengthy orbit. The atmosphere extends far above the surface, reaching altitudes up to 1,000 miles 1,600 kilometers. Despite its thinness, Pluto's atmosphere exhibits layers of haze, composed of complex hydrocarbons that form through interactions between sunlight and atmospheric gases. These haze particles scatter blue light, giving the sky on Pluto a blue tint, similar to the effect seen on Earth. One intriguing aspect of Pluto's atmosphere is the possibility of clouds. Data from the New Horizons mission suggested the presence of 7 bright features near the terminator, the boundary between day and night, which could be clouds. These features are low in altitude and similar in size, indicating they might be composed of acetylene, ethane, and hydrogen cyanide. Pluto is orbited by 5 known moons: Charon, Nix, Hydra, Kerberos, and Styx. Charon, the largest of these moons, is about half the size of Pluto itself, making it the largest satellite relative to its parent body in the solar system. This unique relationship leads many to refer to Pluto and Charon as a double planet system. Charon orbits Pluto at a distance of just 12,200 miles 19,640 kilometers, and the two bodies are tidally locked, meaning the same side of Charon always faces Pluto, and vice versa. Charon's surface is marked by canyons and cliffs, with some regions showing fewer craters than others, indicating geological activity. A section near one of Charon's poles is covered in darker material, possibly due to the redistribution of surface ices. The other moons of Pluto, Nix, Hydra, Kerberos, and Styx are much smaller and irregularly shaped. These moons are not tidally locked and spin rapidly, presenting different faces to Pluto over time. Nix and Hydra, discovered in 2005, are located farther from Pluto than Charon and are believed to be covered in water ice. Kerberos and Styx, discovered in 2011 and 2012 respectively, are even smaller, with Kerberos having a double-lobed shape. The formation of Pluto's moon system likely involved a massive collision early in the solar system's history. This impact could have ejected material that coalesced to form Charon and the other smaller moons. This hypothesis is supported by the similar compositions of Pluto and Charon. NASA's New Horizons mission provided humanity's first close-up look at Pluto and its moons. Launched in January 2006, the spacecraft traveled over 9 years and 3 billion miles to reach the Pluto system, making its closest approach on July 14, 2015. During its flyby, New Horizons collected a wealth of data, including detailed images and measurements of Pluto's surface, atmosphere, and moons. In addition to studying Pluto, New Horizons also explored the Kuiper Belt object 2014 Mu-69, now named Arrokoth, providing valuable insights into the early solar system. The mission's success has paved the way for future explorations of the Kuiper Belt and other distant regions of the solar system. Pluto's reclassification from a planet to a dwarf planet in 2006 by the International Astronomical Union (IAU) sparked considerable debate and controversy. The decision was based on 3 criteria that define a planet. It must orbit the Sun, it must be massive enough to be nearly spherical, and it must have cleared its orbit of other debris. While Pluto meets the first 2 criteria, it does not dominate its orbit, sharing the region with other Kuiper Belt objects. We hope you've enjoyed this in-depth look at the enigmatic world of Pluto. Stay tuned for more fascinating explorations of our universe. Don't forget to like, subscribe, and hit the notification bell to keep up with our latest content. Thanks for watching InfoBurst, where we bring you the wonders of science and space right to your screen. See you next time.